Welcome back friends to Skill Raptor, and I am your host Atharva. So today we are going to see how to simulate a catalytic bed reactor, that is a PFR we are considering here, to facilitate a hydro demethylation of toluene. That is, toluene reacts with hydrogen to give benzene and methane. Let us see what exactly we have got, and we are going to do this simulation using DWSIM. We have some parameters which are available. On my left hand side, you can see there is a component and molar ratio. So toluene is 0.3, that is 30%. Hydrogen is 45%. There is no benzene and methane in the field, hence it is 0. And nitrogen, we have an inert gas which is inserted, that is 25%. Also, since it is a plug flow reactor, we are given the length of the plug flow reactor, that is 2 meter, and volume is given, that is 0.0157 cubic meter. Along with that, there are certain conditions on which the reactor is going to react, that is isothermal reactor. So there is no temperature change. Then pressure is 40 bar and temperature is 640 degrees Celsius. And also, since it is a catalytic bed reactor, so there are catalysts which are inserted inside this plug flow reactor. So there is a loading which is given, that is 400 kg per meter cube. The diameter of the catalyst is 2 mm. Along with this, important things which are given, which are related to the rate reactions, that is, what is the partial pressures of hydrogen and toluene. So you can see the values of pH2 and PT. These are the partial pressures, and Kb and Kt are given. So Kb and Kt, capital K and capital Kt, are the absorption constants. The values are given. Kb is 1.39 and Kt is 1.038. Also, a small k is given, which is rate reaction rate constant, you can say 0.087 mole per bar square per kg catalyst per minute. That is the small k value it is given. So this is the configuration which we are expected to work with, and we will see how to put these values into a DWSIM, and we'll see step by step. So let's go on the DWSIM. So I am on the interface of DWSIM, and on top left, click on the file button and press new chemical process model. So this is a simulation configuration wizard. So this step, we are expected to select the components, then select property packages and systems of units. So press on next button. So 5 components we are expected to select. So I can see methane on top, easy. So just selecting it. Then we have nitrogen. Next is toluene. Then we have benzene. In the end, we have hydrogen. So I've selected 5 components: methane, nitrogen, toluene, benzene, and hydrogen. Just click on the next button. Select SWAV Redlich Kwong SRK. Double click and press next. System of units, select C5. Press press next button and finish. Now on top you have settings. So just click on the settings. So we have, you can see we have selected 5 components, and on top select reactions. In reactions, on right window, click on add reactions and select heterogeneous catalytic. This will allow us to configure. So what all things we want to include? That is methane, then toluene. These are the reactants which who will be actually reacting. So that's why I'm not selecting nitrogen here. Then base component is toluene. So I'm selecting toluene. Now stoichiometry. So here the stoichiometry of the products is positive and reactants will be negative. So methane is going to form, so 1. Then toluene is going to react, so -1, and benzene +1, and hydrogen is -1. So we have selected our stoichiometry now. Now the next step is to select certain important parameters. So basis is partial pressures. So as I said in the formula which was given for rate constant, so partial pressure was given. The fugacity values were not given. So that's why I'm selecting this. Phase is vapor phase. Then we need to see uh, the equation which I said that the rate constant equation is given in terms of partial pressures and absorption constants kT and kb. So we need to put that correctly here. So on top we have, so you can see here, so on in numerator on bottom side you can see it's 0.087 into R1 into R2. So R1 is the reactant, R1 into R2, and denominator is 1 plus Kb, that is benzene. So benzene is our P2, that is product 2. So that's why I will write 1.39 into P2 plus 1.038 into P1. That is not P1, sorry, that is Kt, that is toluene. So toluene is my R1. So R1. Also units we need to see, bar, it is given in bar, and rate units you can see it is given in mole per kg per minute. So mole per kg per minute. Please remember that we need to select the units very carefully. Press OK. Now I need to configure my material streams. Select material stream and just drag it. Let me configure it. Speed stream, just keep the name. Then temperature we said 640 I guess, and bar 40 bar, and mass flow you can just write 100 for time being, and compound amounts. You can see compound amounts. Toluene is 0.3, so I'll just make changes. 0.3 is the toluene. Then nitrogen, I think it was 0.25, and the remaining, which was methane, was I think 0.45, and benzene is 0, and hydrogen is 0. Oh, I guess methane here is 0, and hydrogen is 0.45. You can see nitrogen is 0.25, hydrogen is 0.45, and toluene is. So now we have kind of completed. So just click on accept changes. Now this is the one, and second we want to set up our reactor now. So just click on the reactors and scroll down, so you'll see a plug flow reactor. Just drag and drop. Now let me configure the plug flow reactor first, and calculation mode is isothermic. As you can remember, we said that it's isothermal reactor. Then dimensions we need to set. So reactor volume is 0.0157 I guess meter cube, and tube length we said it was 2 meter. Okay. Then we need to also select catalyst info. As I said, there is a catalyst loading which was given, that is 400, and catalyst particle diameter was also given 2, and one more information we need to add, that is catalyst void fraction. So how much how much is the space empty? So generally it is taken as 0.4, that is 40% is space is empty when you fill up a catalyst, and 60% is filled by the catalyst. Now our reactor is almost we have configured it. Okay, so now it is configured, you can see, and let me just run the solve button that is on top. Just press solve, and system is calculating. The calculations are done. So on left hand side you can see the conversions. So it says toluene is 99% converted and hydrogen is 66%, and you can see the concentration profiles. Also you can try to look at these profiles and export it. There are different ways to show in another window. So you can see the how the reactor length versus the pressure, how it is varying, and the conversion. So you can see the toluene is getting utilized, and then we have hydrogen which is also getting utilized. So toluene is getting utilized very fastly, and benzene will get formed. So this is how you can use DWSIM to do a catalytic reactor simulation, and so you can, so there are many other methods to do this, and this is one of the methods and one of the very simple reactions we have taken. So kindly like, subscribe, and share my video so that we will be able to make more and more such interesting stuff. Till then, thank you very much. Bye bye.